Good afternoon. We are missing few, but I think we have to make a start. So first of all, welcome to PELVITRACK first open day. I would like to extend a warm welcome to our distinguished speakers, consortium members, guests from outside Terracotta, and our online participants who are joining from different parts of the world. Today is a special day for PELVITRACK. We are celebrating 1 year of innovation, collaboration, and progress. And it's not only to showcase what we have achieved, it's a good opportunity to continue engaging the discussions and looking forward to the next steps next year. We have a program, exciting program of speakers who will share their insights on the work and the progress they have done so far for PELVITRACK. I would like to introduce our first speaker, Professor Anne-Sophie Carreau, who is the coordinator of the PELVITRACK project and a professor of material mechanics at IMT LS. Professor Carreau has authored more than 60 publications and have participated in numerous national and European conferences, including coordinating the EU-funded project PELVITRACK. Professor Anne-Sophie will talk to us today of an overview of PELVITRACK. Please.
Thank you, Mona, for the introduction.
Yes.
This is a presentation, an overview of the PELVITRACK project. It's not very easy for me to present this project because it's many years of work, in fact. But yes, I co-lead this project. It's important to say it with Sarah Yakinta, which is assistant professor in mechanics. Sarah is here, but everybody knows Sarah. So I will try to do my best to present the overview of the project before letting my colleagues going in depth in the presentation of the project. So this is the disclaimer. So the PELVITRACK project is about pelvic floor dysfunction with a focus on perineal trauma. This is a major challenge. So just to remind, the pelvic area is presented in this illustration. As you can see, there are some organs, bladder, uterus, and rectum. And the lower part is the pelvic floor, and between the anus and vagina, there is the perineum. The perineum is a very complex tissue, and as you can see on the illustration here, it's a multi-layered tissue composed with skin, fascia, muscles, and so. So it's not very easy to understand what's happened in this kind of soft tissue during the stretch. So the PELVITRACK project has a website here. You can go and visit it, and there is an information in this website about the number of new patients diagnosed with pelvic floor dysfunction So here you have the number. It's since the beginning of the project, so 1 year, since 1 year. So as you can see, it's a very huge number. So we need to study that. So why pelvic floor dysfunction are a problem? Because there is some pain, some incontinence, organ prolapse, dyspareunia, chronic pain, sexual dysfunction, and all of these can limit daily activities, reduce quality of life, lead to social isolation and isolation, and surgery. So 1 woman over 3 are affected by pelvic floor dysfunction, so it's a very large number. So what are the causes? 4 main causes. The first one is pregnancy and vaginal delivery. The second one is aging and hormonal changes. Another one is obesity and chronic pressure. And the last one is repetitive and mechanical loading. So the project focuses on the pregnancy and vaginal childbirth because it's the main risk and the major mechanical loading, in fact. So we understand 1 woman over 3 childbirth is a major risk. So on the website you have another number which is related to the perineal tear. Sorry, here, which is also a very high number. So we have to study pelvic floor dysfunction, and we can study first the childbirth and the tears that occurs during childbirth. So during vaginal birth, you have, of course, baby, and as you can see, you have stretching in perineal tissue, and in some cases, the perineal tissue are not able to support the stretching, and so you have some tears. Here, it's a very severe tear, but sometimes you have minor tears, and it could be okay, and severe one, it's more difficult. And the severe one are called OSIS for obstetrical anal sphincter injuries. So we must avoid this kind of tears. Okay. So why we have to avoid? Because in short term there are some pain, some wound complication, incontinence, dyspareunia, and so. And in long term, you can have a very chronic pain, pelvic organ prolapse, sexual dysfunction, and so on. So we must study it. So the project is about childbirth. What are the main risk factors that can conduct it to OSIS? You have a very long list of factors. The first one are related to the delivery. Because we can use instruments as a spatula, forceps, or vacuum devices, or it can be also related to long labor. Second factors can be related to the baby with a very high weight, or to a fetal malposition. And the last one is about the patient. It can be the first delivery. It's a risk factor, an advanced maternal age, and a short perineal body. All of these factors are risks that could be conducted to OSIS. So I think that this slide is interesting also. You have the percentage of perineal tears around across Europe countries. So the percentage is very high in all the countries, and the OSIS is not so high, but there is a percentage. And what is interesting is that the numbers are different between the country. So maybe the tears are not only due to patient characteristics, but also to practice and to delivery condition. So I think it's interesting also to focus on that. So we need to understand better what's happened before and during vaginal delivery. So, is it possible to prevent tears and oasis? There are many strategies. So, at first, perineal support or delivery techniques. You can see here we can use episiotomy to relieve the stretch. We can use a strategy of the head to control the head trajectory. We can use some maneuvers. Okay. It's possible also to use different maternal position, standing, sitting, squatting, kneeling. But also we can use perineal massage, warm compress, burst trainers. There is a lot of solutions. But in fact, there is no clear answer about what is the best way to relieve the stretching and to avoid tearing. So why? Because in fact we do not know the mechanical behavior of the perineal tissue. We know, but not all. So okay, but how clinicians and midwives protect the perineum during childbirth? At first, they see, they observed, and they take decision, but it's too late because the tearing is here. Okay, so and more when they see the damage onto the tissue, maybe the internal tissue are already damaged. So it's too late. So all of this is about clinical experience, and it's subjective and very operator dependent. So clinicians have to take very quick decisions without objective and personalized biomechanical information. So finally, the stretching in perineal tissue is a biomechanical issue. There is a clinical reality. The tissue whiten. There is a risk of tearing, and there is no time to decide. So, from a mechanical point of view, the stretching and the whitening is related to rupture. And it's in the mechanical field, it's a topic about nonlinear soft tissue mechanics with considering the damage. So the idea of the project is to combine biomechanics, clinical tool, prototype, and clinician. So it's from observation to propose prediction. So four main topics about the project is to quantify perineal trauma during childbirth, to identify a damage marker, a damage signature, to provide a real-time hybrid monitoring, and to provide also biomechanical measurements. So the idea is to bring biomechanics from the laboratory to the delivery room. So okay, it's a medical priority, but how can we help clinicians, midwives, and patients? So the first idea is to use the own device of physician. Could be elastography, thermography, electromyography. Here you have an example of a thermic map on a sample, and here it's elastography. We can also propose other devices as suction, color, texture analysis, stereophotogrammetry, or we can also propose prototype like a kind of instrumented palpation. Okay, so all of these devices are related to. They must be adapted to real clinical conditions, but they are related to different fields of expertise. So you have acoustic, thermal science, electrical science, mechanics, optics. So this is the reason why PELVITRACK consortium is a multidisciplinary consortium. Okay, so here you have all the fields that are involved in PELVITRACK project. And the consortium is across Europe. As you can see here, we have 14 European partners composed by clinicians, engineering, and researchers. And here you have the list for the France consortium. So you have school, engineering schools, labs, and hospitals. Here in the last part of the slide, sorry, hospitals. So across Europe, you have some labs and engineering school also, and companies also. And we are here in Zaragoza because tomorrow is the plenary meeting, the annual second year meeting for PELVITRACK. So this is the reason why we are here today. And we have also in Switzerland one engineering school and another hospital. So here is a photo of the consortium. It was taken during the kickoff meeting in Alès. It's only a part of the consortium because some of the partners were online also. Okay, so as you can see, it's quite a big number of partners for this project. And here it's just to have an idea. Here it's the reminder of the fields. And as you can see, all the partners are needed for the project because we need expertise from all the fields. So the consortium was built to answer to all the parts of the project. It's okay for the photos? Okay, more for the project, we have also a supervisory board that help and guide us. It's very helpful also. So we have, I'm not going to read all the name, but they help us a lot, most for guidance, in fact. And we have also an ethical advisor just to check that everything is ethically correct for the project. So just to finish, the project so combine ex vivo biomechanics test on pig perineal, then multimodal sensing, as you've seen, with a device benchmarking. A multi-scale modeling approach, and a clinical translation also approach. So the long-term vision of the project is first we are studying childbirth to understand to predict the trauma, but we want to also use after the end of the project. We would like to use the device in the postpartum period, just to follow the recovery of the perineal tissue. Then during the adulthood with monitoring tissue fragility, and also during aging, we could maybe prevent pelvic floor dysfunction by proposing personalized prevention and rehabilitation. So now let's go inside the project with the work package leader. Thank you for your attention.
Now, our next speaker is our amazing host, Professor Stefania Pena, who is a full professor of solid mechanics at the Department of Mechanical Engineering here at UNIZAR since 2017. She has also been a visiting scholar at the University of Southampton, UK, and Joseph Fourier University, CNRS, of Grenoble in France. She's an expert in computational mechanics with special emphasis in numerical modeling of soft biological tissues. Professor Pena will talk to us today on the biomechanical modeling of perineal tissues, key insights, and relevance for personalized assessment.
Okay, thank you for your kind introduction. So I will try to explain the work that we are doing during this project related to the modeling, the constitutive modeling that's related to the work package 3, but I prefer to say biomechanical modeling, not talking about the work package. It's not that is a work that developed all the work package, but I focus in some parts of that. This is the disclaimer for the European Council. And I would like to focus the thing that our objective is not develop a constitutive modeling. Our main objective is to find the mechanical biomarker. The constitutive modeling is a tool in order to find that. So that means that we need to integrate with a lot of groups, a lot of teams, a lot of work package, multidisciplinary things in order to find this biomechanical marker in order to put inside our digital twin. The idea is we have, that presented later, a lot of experiments in order to understand what happened inside of the different tissues in the perineum. We need to reproduce these experiments, but reproduce the experiments not only reproduce the side or the way of the cures, we need to reproduce the mechanical behavior, understanding what happened inside of the tissue. We have fibers, we have a lot of things we need to introduce in our constitutive models. And after that, we give these models to the computational, the digital twins team in order to introduce these models in order to find the real biomarkers. So it's a continuous interaction between the different topics, different ideas. Okay, I will try. This is an open day. This is an open day symposium. So I will try to reduce the question as less as possible. So, but I need to that you understand the requirements that we have in order to propose a constitutive model. The first one is we need to reproduce all the deformation range, not only the healthy range of the perineum. We need to go more than for the non-physiological range, strains, because during the moment of the labor, the tissue are very stretchy. So we need to develop models in all the range. The second one, we need to incorporate in the simple way, but we need to incorporate all the possible physics inside of the constitutive models. For example, the direction of the fibers. For example, we have a viscosity, we have damage, we have muscles, we have collagen, we have different things. So we need to introduce all of them put together in our models. The second one is we need to develop a mechanics. So we need to cover all the physics inside. That means the thermodynamics. That means that our constitutive models will be in a good way. And this is, for me, the most important and the most complicated thing. The models will be as simple as possible with the smallest number of parameters that is possible, but we need to reproduce several physics. So we need to balance between both. So the idea is to put together the test, the microstructural analysis to understand the tissues. We need to incorporate different ways to put this one in models. We need to incorporate the microstructure of the tissue. We need to incorporate different phenomena. We are talking about damage, fracture, viscoelasticity, activation of the smooth muscles, the fibers, muscle fibers. So we need to put all together in one constitutive model. And this constitutive model is the model that we use to find the biomarker. So how to do that? Okay, at the first, we need to understand what happened. So we have a lot of experiments that provide us people for the experimental team. For package 2, we need to analyze the anisotropy. If we have different behavior depending of the direction in the circumferential area of the vagina, in the longitudinal one, we need to analyze the dissipation energy. That is a good biomarker, for example, for viscosity, for softening. We need to analyze the damage. We have damage. Where is the damage? Due to this damage. So to do that, we perform analysis of the old experiments. This is an example, the one experiment that we have. Well, this is a cycle experiment when we can watch that at different levels of the strain. Maybe this is physiological, maybe this one is non-physiological, that maybe this is the range of the label. So we need to analyze all. We analyze this one during several cycles, because during the label there are several cycles of contraction. So we need to compute how the energy is dissipated. That means that we put all the work, and after remove this work, not all the energy is recovered. That means dissipation. So we need to compute the dissipation, the evolution of the dissipation, so the evolution of the dissipation, depending on the cycles. We need to analyze what happened with the rupture, how the tissue rupture, where the tissue rupture is very important. And we analyze, for example, the influence of the velocity of the strain rate, because the contraction during the labor is very fast. So we need to characterize this one. This is due to viscosity. So we need to characterize the tissue at different strain rates. And for example, we analyze that for the elastic range, the strain rate, the speed is not relevant, is not a hot topic. But for the energy dissipation during the labor, the strain rate is very important. So we need to take into account this one due to incorporation, for example, viscoelastic models in order to reproduce this phenomenon. We can find also, for example, that the rupture is different at high speed, at low speed. That is a real clinician thing that people watch. And we also have, for example, different tests for relaxation in order to analyze how the evolution of this dissipation, because we need to reproduce the viscoelasticity, for example, and the dissipation due to reorganization during the first cycle, due to the organization of the fiber, the reorganization of the tissue. So to do that, we need to analyze, for example, this corresponds to removing the viscoelasticity due to a relaxation to get the equilibrium. So with all these things together, we took some decision or some hypotheses that are very critical in developing our models. The first one is we are focused into tissues. In this case, the anal mucosa and internal anal sphincter, because it was the first experiments that we have. We watch that the anal mucosa is isotropic, so that means that the model is the simple one. And we have anisotropic for the internal anal sphincter, so we need to develop a more complex constitute model. For example, for the viscoelasticity, we get the same, and we get that our models, the dissipation energy doesn't depend of the strain rate. So for us, it's a very good news, but means that our models are as simple as possible. And for example, for the softening, also is isotropic, so that means that we maintain as simple as possible target. And again, for the damage. The objective. Okay, the objective is what? We need to develop, we need to choose one model. But we have different models because we have different groups with this know-how. So we need to test which model is better than one. Depends. All the models are very well, but we need to find the balance between the number of parameters and the error, the good fitting, the good reproduction of the mechanical response of the tissue. So we analyze developing a benchmark for all the groups. This is what? That you select different experiments, or people put their thought into these experiments. We need to define different variables, different metrics, but all the same metrics for all people. It's very important in order to compare different models. We need to incorporate viscoelasticity, softening, damage, dependent. Obviously, each model is different, with different approach. So the biomarkers that we can find will be different, and we fit them. For that, we take different decisions. For example, for the hyperelastic, we found that the simplest model for the soft tissues is enough. So we take one. That is only 2 parameters. And the different groups develop these models to fit in that. This is the idea. Another important thing is the objective is a patient-specific model. So we can take another decision. We fit sample per sample or fit the mean properties. Okay, in this case, the final objective of the project is develop a patient-specific models. We decide to use specific samples, not the mean of the data. This is the metrics, sorry, equations. Okay, this is the metrics that we decide to use. This is about the fitting. This is, we have for the hyperelastic, we decide to choose the simplest one because we have only 2 parameters for the isotropic material. So, and we chose this another constituent law. This is the Deborah law. This is the Gasser, Holzapfel and Ogden law, because it's the simplest one and is implemented in all commercial codes. So we fit very well. We test another constituent models, but have more parameters than this. So the idea is to reduce the number of parameters at the minimum. And finally, we need to a very important problem, too many parameters. So we need to define a very good strategy to fit the models. We have different choices, trial and error. This is the try to different parameters. It's not an efficient way, and there is no unique solution. We can use the analytical solution in the cases we have, and we can use different scripts in order to get these mechanical properties. Each group use their strategy in this way. An example to finish. Unisar example. We use the strategy to develop a script in order to don't compute the analytical solution. The idea is to use MATLAB for the optimization, a very commercial code, very famous code, with the Abacus. This is one of the best commercial codes to simulation in biomechanics. So we propose this model, sorry, equations, but I don't explain the model. The model includes the fluid in the incompressibility part. The model includes the viscosity in this part, the viscoelasticity of the tissue, incorporates the hysteresis, the fatigue of the tissue, and incorporates the energy dissipation due to the reorganization of the tissue at the first cycle. What is the problem? 11 parameters. Too many parameters. So we develop different sensitive analysis in order to find if we can reduce this model dependent of the influence of the parameters. We can fix some parameters and fit the other ones. It's a strategy. We are now looking for this strategy. But the best thing that there is no connection between parameters. So we can fit one, not affect two other ones. And this is the first results that we have. This is fitting the cycle test that I showed you before. With the different levels, we can fit the fatigue, the hysteresis of the tissue. We can compute the hysteresis, the dissipation energy due to the different cycles, and we can compute the peak of the stress in the tissue. So it's a good results for me. It's the first result, it's a hot results. But the best thing that it is for calibration. Calibration means that I use the experiments to compute the parameters. The idea is I put these parameters in other different experiments in order to watch if this model can predict totally different tests. And the results surprise me, but it's not too bad because we get a very good fitting. It is prediction, it's not calibration. So with this model, we can reproduce other different states of the tissue. This is the objective. So the idea is to develop a very good constitutive model in order to find this biomarker. How to find these biomarkers, for example, will be the energy dissipation that we can compute with these models in the computation of the work package 4 team, or using directly, for example, the constitutive parameters that we can fit. Depends. We are looking for now. So, as conclusions, the identification of the mechanical biomarker for perineal tissue needs to find viscosity, softening, damage, fatigue or hysteresis, that is more or less. We found at the moment that the internal sphincter needs a very complex model, but for example, anal mucosa, we can use a simple one. Considering all the phenomena, if we want to test all the biomarkers, we need a very complex material models with too many parameters. So maybe we need to decide how many effects are more relevant to the label in order to reduce one. And the most important things, select the appropriate model needs a balance between complexity and very good taking account all the phenomena, the inelastic phenomena, the damage phenomena during the label. So that's all. Thank you so much.
I would like now to introduce our next speaker, Dr. Baptiste Pierre, who has earned his PhD in mechanical engineering in 2013 and is currently an assistant professor at Mines Saint-Étienne, France, within the Symbiose INSERM research unit. His research specializes in the mechanics of rupture of soft biological tissues, utilizing in situ experimental methods and numerical modeling to understand tissue damage. His talk today will be on the mechanical characterization of perineal tissue, ex vivo testing strategies, and key mechanical findings.
Thank you so much for the kind introduction. So the work I will present today is actually very much related to what Stefania presented just before. It comes, let's say, at a preliminary step maybe, or a joint step into a constitutive modeling, and is more dedicated to the experimental part to characterize the mechanical properties of perineal tissues. As an overview, this is where we stand. So the ex vivo biomechanics experimental characterization should be closely related, as I said, to the work package 3, which is the modeling, and also in order to feed then afterwards let's say more global scale numerical models of delivery. So what is experimental characterization in this context? So first we have to understand what load these tissues are subject to, and then to try to reproduce these loads in the lab. So as probably most of you in the audience know better than me, these are the mechanics during the delivery process, where gradually the fetus descends, and then depending on the path it takes, it will load the tissues on its way. And this descent is not continuous. It happens progressively with breaks, let's say, step by step during each contraction. And so then when the baby's head arrives near the perineum, you see that the opening is very small for the head, so this opening needs to stretch. So the tissue needs to stretch to let the head pass through. And this stretching, as you can see here, so it's just like an animation, but you can imagine that the tissues will be stretched way over their physiological stretching capability. And so this will, in some cases, induce damage at different degrees, as Sophie presented just before. But yeah, what I want you to remember is that the stretching can be quite extreme compared to what we're used to in the physiological loading conditions of human body tissues. And so, as I said, this stretching does not happen in a continuous way. So the velocity also comes into play. And so in order to try to describe the behavior of this tissue, we need to know different things. For example, how the loading changes with time, how the mechanical behavior of the tissues responds to the rate at which they are stretched, how they respond to the cycles that are applied to these tissues, and also how they behave with respect to the tensile direction, which you will see just after, is a specificity of this tissue is that they do not respond the same depending on the tensile direction. And so we need to see these tissues as engineers and see what kind of measurements we can take on them. And so here, this is the work from a team in the Czech Republic that had attempted to measure the stretching of these tissues during the delivery. So for this, they place, let's say, markers on the skin. And then when the delivery happens, they see how much these markers are displaced. And from this, they deduce how much the tissues have been stretched. And what they found out is that the stretching, as I said, is quite extreme. And so the levels of stretching are extreme, but also what's important for us is the direction of stretching. And here from these images, you can see that stretching is mostly transverse to the axis between the vagina and the anus. And so then what we would like to do in the context of PELVITRACK and with what we have attempted to do is try to reproduce this exact same kind of loading conditions in the lab to try to measure the stiffness and the resistance of these tissues. And so this is what I'm going to present now. So for this, we are working with an animal model of from the perineum of pig. And so we extract this perineum, and then we are focused on the region between the vagina and the anus. From there, we dissect different components. So we dissect the skin, and then we dissect also below the skin other components like the external anal sphincter, which is a muscle, and also the internal anal sphincter, which is another kind of muscle with a different kind of architecture, but also the mucosa, so the anal mucosa and the vaginal mucosa. And these are the tissues on which we will be focused for our experiments. So as I said, because the stretching happens in different directions, we need to focus on like having a way to orient these samples, or at least to record the orientation of the samples when we test them. And so here you see that we, by convention, we will take the tissues of the anus and the mucosas, and then we will take two directions in each case. So let's say internal, external direction, which is along the anus and the vagina, and then the circumferential direction. And for the skin, we'll have two directions, which is the longitudinal one, which is between the anus and the vagina, and the transverse one in the other direction. And this, for the skin, for example, this is this transverse direction, for example, that is in which the tissue is essentially loaded. And so then we try to standardize the mechanical testing. So what is mechanical testing in this context? So the idea is to measure how stiff a tissue is, and also how resistant it is to stretching. And so for that, we cut part of a specimen, and then we put it in a tensile machine that will apply stretching to the tissue, and then measure how stiff it is. And so for this, we have to standardize the process at different levels. The first one is during, as I said, for the collection of the tissue, then also for cutting the tissues, and finally for testing. And so overall, our study focused on 118 samples extracted from 10 animals, and the samples were frozen before testing. And so this is what our tensile machine looks like. So here you can see that the sample is stretched between two clamps, and here is a detailed view on the sample during stretching. And so what we want to reproduce now is the kind of stretching that the tissue sees or is subject to during the in vivo loading conditions. So for this, we had a kind of a brainstorm about how to reproduce this, and the first thing that came out is that we need to apply cycles, loading cycles to the tissue. The velocity of the cycle can be based on the contraction pattern, which is kind of irregular, as you see here on the top graph, but we chose to do the test in a more regular way. And so we apply this cyclic loading pattern, and we progressively increase the stretching amount, so the strength level, as long as the test progresses. And what do we record from this test? We record the force that is applied to the tissue, and we record the displacement. And so this is the kind of graph that we obtain. So this is the stress versus strain graph. And so in engineering, this is a very typical graph that tells us a lot about the mechanical behavior of the tissue. So you can see that the stress is a measure of the tension in the tissue, and the strain of how stretched it is. And you can see here that the different tissues behave differently. So the ones that are on top are the ones that are the stiffest, and the one on the bottom are the ones that are less stiff. You can also see something that is not quite typical of other engineering materials, that the stress versus strain response is nonlinear, meaning that the more we stretch the sample, the higher the stress. And so this is typical of biological tissues. So what you can see is the different tissues are very different in terms of mechanical behavior, which is very important to know and to implement in the models that we want to develop within this project. Here we have a comparison of the testing directions for each tissue. So for example, for the anal mucosa, you have the internal-external direction in red and the circumferential direction in blue, and the average responses are quite similar in the two directions, meaning that the tissue behaves approximately the same in the two directions. What we can see is that for the internal anal sphincter, for example, this is different, meaning that the circumferential direction is stiffer than the internal external direction. And so from this, we can categorize the tissue that are isotropic, meaning the response is the same in both directions, and the tissue that are anisotropic, meaning that they respond differently to the tensile direction. We also did a microscopy on this tissue to see whether this mechanical behavior could be related to the structure of this tissue, and especially the network of collagen fibers, which bring stiffness to this tissue. And so this is still preliminary work, but we were able to also detect some preferential orientations for the tissues that are anisotropic. So for this part of the characterization campaign, we focused on dissecting the tissues and testing them individually. However, the perineum, it's a complex structure, but the tissues, they are kind of linked together and they work together. So in parallel, we also try to first observe the structure of the perineum, let's say, without dissecting it. So for this, we use the micro-CT tomography. And so we're able then to, here you can see the view of the perineum with the vagina, which was cut open on one side, and the anus on the other side. And we're able to see how the architecture of the perineum is made especially the orientation of the different muscle structures, and how the fibers run with respect to the direction of the perineum. And this is also something that is very complementary from the, let's say, the more unitary tests that we do. And finally, so this is related to what Lucas will present just after. We also try to make a loading that is more functional or more representative of what the perineum sees during childbirth, by having a kind of clamping mechanism that would clamp the whole perineum, and then having a balloon that we will pull through the perineum, and then apply a more functional loading that is also quite complementary from the unit test. And this is what I would present. So that's all. Thank you for your attention.
Thank you. As you know, we'll have questions and answers at the end, so obviously we're leaving the best till last.
Now I would like to introduce our next speaker, Professor Luca Mezzin, who has graduated in electronics engineering in 1999 and subsequently received his PhD degree in applied mathematics from the Politecnico di Torino in Italy in 2003, where he is currently an associate professor in biomedical engineering and the supervisor of mathematical biology and physiology group at the Department of Electronics and Telecommunications. And he will talk to us today on the investigational devices and prototypes, preliminary experimental results. Professor?
Thank you very much for the introduction. So I will try to explain to you a few of the methods that we are using to characterize the tissues. For each of these methods, I will introduce very rapidly the concept, and then some examples of measurement. So let's start with elastography. In elastography, we can get some information about the rigidity of the tissue inside of the tissue. Looking from outside using an ultrasound transducer, we can make a perturbation, a mechanical wave which is propagating within the tissue, and the velocity of this wave is can be estimated by ultrasounds again. And given the velocity, we can estimate the shear modulus, and so the stiffness maps, which is superimposed to the anatomy of the tissue provided by the ultrasound. So here we can see some experiments that were performed in Besançon on ex vivo tissues. So we have here some applications on porcine perineum, and then well, the same can be easily performed in vivo by using the ultrasound probes in this way, by targeting the tissue, the perineal tissue in which we are interested. And this is an example of rigidity map superimposed to the anatomy, which is visualized thanks to the ultrasound. Another method is stereo photogrammetry, in which we have two cameras which are making a video of the tissue of interest. The two cameras are synchronized, and so there is the possibility of estimating the points which are homologous taken by the two cameras, and in this way, by triangulation, we can estimate the surface embedded in 3D. And looking at all the frames, we can understand the deformation of the tissue in time. So we have an anatomical reconstruction of the external part of the tissue of interest. So we get a spatial distribution of the strain looking at the subsequent frames in the video. The region which has which shows the maximum strain is the most critical. We can expect that is the most critical region, and we can look at the strain and the displacement, etc., over time. So as in these examples in which you see two contractions and then the delivery, and so we can check the displacement, in this case, of a specific region of interest over time. In the case of thermography, this is another imaging technique, which is non-contact, non-invasive, and so it would be very, very useful to characterize the tissue without having any interaction with it. By infrared cameras, we can estimate the temperature of each pixel in the visualized frame, and we can see how the temperature changes over time. For example, as in this case, during a traction test on a tissue which was sectioned. Within PELVITRACK, we had the possibility to make a test in Besançon, both in tissues which were sectioned and so separated from all the other parts, and so we can see how what is the profile of the temperature along some lines of interest, and we can see how the temperature changes over time during a traction test. And then there were also some measurements on the full perineum, and here we see again some region of interest and the temperature over time during one of the tests that Baptiste discussed previously, in which there was a simulation of a delivery. Then colorimetry, another image method, imaging method. Also in this case, there is the possibility of exploring some regions of interest, recording a video, and from the video we can compare different frames of the video and understand where different points are moving, and then we can understand what is the stretch, for example, and we can characterize the stretch by some measurements, the Jacobian, for example, which is measuring the variation of the area of our region of interest, or other principal strain directions of this. Then we can also study the color of the different region, which can be a way to characterize the effect of the strain, and other indicators. So we see here some examples of mechanical parameters during a test of inflation, in which the balloon was inflated in order to simulate the growth of the child. And then there was the delivery, which means that the balloon was that there was the traction of the balloon, which exited as in the video that Baptiste showed before. And here we see the estimation of these parameters. For example, you see that here there are monotonic variations. These are different testing tissues. And so you see monotonic variation, which indicates that the area of the region of interest, for example, increase over time. In this case, we are showing the Jacobian. During the delivery, the variations are quite different, so it's not a stable behavior, and we should work on that more. Here are other parameters, the variations of the color, which is also a monotonic variation during the inflation. And then there is this jump, which is quite consistent during the delivery. The entropy, which is measuring the complexity of the texture, and in this case, you see that the entropy is are quite different, and so we should work more to understand this. Indentation. In indentation, there is an indenter, a spherical probe which is displacing our tissue in a certain point, and there is a load cell which is measuring the force provided by the tissue to the tip of this indenter. The experiment is split into 3 phases: a phase of loading of the indentation, then a phase in which the tip is all fixed, and the force is measured over time in order to understand the relaxation of the tissue, and then the force is removed in a controlled way. And we see some results on dragon skin, which are some tissues with known mechanical properties. We see here the force applied during the indentation, then the relaxation, so the case in which the probe is fixed and the tissue is relaxing. The force control test, where you see the force which is released, and as a consequence there is a displacement of the tissue which is coming back to the original position. And you see how the different mechanical properties of these prototypes of skin allow us to get very different responses. Then we have suction. In the suction test, there is a depression along a ring, and in this way, the central part of the skin, the target skin, is here between the vaginal canal and the anus. So by making a depression along this ring, the central circular region is stretched, and if this portion of tissue is isotropic, the circular region maintains its circular shape. Otherwise, we get an ellipsoid indicating the direction of large rigidity or most soft material. So this is an example in which there was the suction test. By a camera, we can see how the tissue is deformed, and by tracking the movement of the different points, we can understand what is the stretching of the different points. And in this way, we can understand that in this specific case, from a circular initial region, we obtain an ellipsoidal region, and so there was an anisotropic tissue, and we can understand in which direction we have the maximum strain with a constant force applied in all the circular direction. Finally, we have an electrical property, which is impedance, which can be studied by considering ohm loads, which means that the impedance is the ratio between the difference of potential induced by a current which is flowing to the tissue. The idea is that when you apply a low frequency current, the current is flowing in the extracellular fluid, but with high frequency currents, you have that the current is also entering the cell, and so by exploring different frequencies of the current, we can get some electrical parameters which characterize our system. A simple electrical model is something like this, in which the membranes of the cells are modeled like a capacitor, and then there is a resistance which describes the intracellular region, and the extracellular region is characterized by another resistance. We know that this capacitance is an open circuit for low frequencies, and so for low frequencies we only see this resistance here. For high frequencies, this capacitor becomes a short circuit, and so we have the parallel of this resistance, which means that the total resistance decreased by increasing the frequency. But we have a major problem, which is that of the contact between the electrodes and the tissues. This contact has an impedance which is not stable, and it is different across different electrodes. And so there are methods. We apply the four-wire measurements, which means measuring the difference of potential after the contacts. In this way, instead of measuring the sum of these three impedances, which are the impedance of the tissue and the impedance of these contacts, we measure only the impedance of the tissue ideal. Okay, the impedance was applied in many fields, including body composition, impression, galvanic response. So we expect that it could give some indications in our case. We developed a new device, even if there are some commercial devices. We decided to develop a new one, which is multi-channel and multi-frequency. Why? Because having more channels allow us to get a different distribution of the current within the tissue, with currents entering from closed electrodes and the potential measured from closed electrodes. We have this current which is flowing only in the surface of the tissue, and then by extending the distance between the electrodes in which the current is introduced, we have a current which is going deeper, and so we can study different or record information from different areas in the tissue. These are examples in which different channels provided different impedances, and we explored a large range of frequencies in order to get information about the low frequency components and the high frequency component. By interpolating this data with a mathematical model, we can estimate the parameters that you find here in this case. So, as a conclusion, the properties of a biological tissue can change much during deformation, because there is a stretch, there could be some damages, and so we can try to characterize these effects of the strain of the tissue by different techniques. We adopted a multimodal method in which different imaging or signal processing techniques were applied in order to characterize well our tissue. And we hope that with these measurements we can characterize both mechanical, thermal, bioelectrical, etc. Properties of our tissue, and try to effectively infer the variations due to the deformation. Thank you.
Next, I would like to introduce Dr. Vit Novacek, who has graduated in applied physics in 2001 and has received his PhD in applied mechanics from the University of West Bohemia in 2006. Vit has spent over 10 years in France and more than 8 years in the medical device industry. He is currently a researcher at the New Technologies Research Center of the University of West Bohemia in Pilsen, Czech Republic, since his return from France in 2018. His research interests include both experimental and computational biomechanics with a focus on women's health. and he will tell us today, his talk is about numerical simulation of childbirth.
Thank you, Mana, for your introduction. Ladies and gentlemen, good afternoon. It is a pleasure, it's an honor for me to be here. I will tell you a few words about modeling and simulation of vaginal delivery. Modeling and simulation is an important component in diagnostics, prediction, and prevention of injuries. PELVITRACK project has actually many unique features, and one of them is that it brings together, I'd say, like 3 major European teams working in vaginal delivery modeling and simulation. There are Saint-Halil in France, ING in Porto in Portugal, and the University of Slovenia in the Czech Republic. We all have slightly different approaches. We'll bring our expertise together in order to put in place, develop and put in place a dedicated PELVITRACK model. So I'll tell you a few words about person-specific geometries, loading scenarios, and clinically relevant indicators. But before we start, I'd like to go quickly through the objectives of this work package dedicated to modeling and simulation. So our first task, our first objective here was actually to review the loading conditions from our already existing simulations. And the purpose was to go through and observe actually what are the details like the stretch, strain, deformation, stresses, what are actually the conditions experienced by the tissues during the delivery. And the objective was to get together all this data and provide a feedback to the work package dedicated to the characterization of these tissues, to inform them about what are actually the ranges of, deformations and the loading in general. The second objective of this work package, the second major objective of this work package, is to integrate the constitutive description of these tissues. And these you have already seen are being developed in work package 3. One of the major actually components here is the parametrization of these models. I will go into details just in a second. We need actually to parameterize these models because we are all different. We want to have these models person-specific. It used to be like that many decades ago in biomechanics, that one model fits all. That's not true anymore, right? We need a personalized medicine with more focus. And this should also bring some cost savings in healthcare in general. So this parameterization is actually of the paramount importance because we need to run a parametric study. So if we have parameterization, we can generate a lot of different models for a lot of different individuals and run these parametric studies to work out what are actually the most important, most influential parameters in the process of vaginal delivery. And this information in the end should actually lead us to some sort of model reduction. We will use this information, the relationship between the outputs and inputs, and we'll try to work out something simple than our costly and time-consuming finite element models, so that we will get something much faster in terms of prediction and diagnosis, something that would be really applicable and usable in the clinical settings. So in terms of the tasks, this work package is divided into 3 tasks. And what I have here is just a short description of what these tasks are about. So we started with the review and literature data, our own data, our previously generated data on a pelvic floor only conditions, in order to provide feedback to the work package and works on the tissue characterization, because we will need their data to come back and feed our models. We also started to define clinically relevant scenarios and the list of factors we need to consider. And we started working on this parameterization, because this is really the most important step and goes back and forth. So we need to take this into account from the very beginning when we start to develop our models. We need to bear in mind that they have to be parameterized. The second task will be to establish the list of levels, actually, the levels of the previously developed, for the previously identified factors. So the levels means like the values. How many values do we need in terms of stiffness? We go from A to B, and what is the step, right? So this is something which will tell us actually how big our parametric study will be, and we need to, be very careful. Okay, it can grow quickly, right? And we need to make it feasible. So we will very likely need to do it by chunks, by small pieces. This will help us to define the design of experiments. So this is actually the relationship between the inputs and outputs. So we bring the inputs, we run all these simulations, we work out the outputs, and now we try to relate them somehow, simplify this. So we need to define this design of experiment and run the parametric study. And finally, we'll need to create some surrogate models, some reduction of model, do some reduction of model to analyze this relationship and provide this real-time predictive capability to the project. Today, I'll be talking all about these two, although we already initiated some of the further activities, just to make sure that in terms of feasibility, we're good and we can place, the right processes in place. So why do we need person-specific models, person-specific? We start with geometries here. We don't have all the material data and so on. Let's start with geometries. So there are different levels of personalization, starting with the generic model. So one model fits all, one model for the entire population. Another level is like population-specific models. So these models, they do fit like a central property, like typical mean or median, whatever it is, for a given range, of value in a reference population. So this could actually be some sort of stratification of the population depending on the disease. And finally, we have the Holy Grail. Here we have this subject-specific model. So this is really one model per person, personalized medicine. And this is what we do target in PELVITRACK. So how do you do it in terms of geometry? We decided to start from a generic model. So as a generic model, we used a model developed by the University of Birmingham also. This model is based on MRI images and manual segmentation of these images. Now, especially in this field, in vaginal delivery, we do face a lot of challenges, especially the lack of data. So most of the models, not only within our consortium, they're not project, but worldwide. Most of these models are based on MRI images of healthy asymptomatic nulliparous subjects. There's really a scarce or almost non-existing data on pregnant. I don't say we do not have any, but it's really rare. So this is one of the many simplifying hypotheses we actually have to accept and we have to do. And we'll see that it can have some consequences. In terms of parameterization, there's several ways how to do it. We opted for our technique, which is based actually on mesh morphing, which uses a set of landmarks, a set of points on tissues, right? We started with only the pelvic bone, but quickly we understood we need to add more specific points for some soft tissues. There's a lot of variabilities. We'll see later on the next slide. So we start with these landmarks. We use them as actually as control points, and changing these control points, their coordinates, enables us actually to generate a completely new model. So this is how we parameterize, how we render model subject specific. It means also that we need these MRI data for every subject, and we need these landmarks, and it's a lot of manual work clicking on the images. In terms of accuracy, you really need, very good eye. You need a lot of experience, and even two experienced operators can, select for same point actually different coordinates. And the difference, I was a little bit surprised. We did some statistics on this, and we have a file of like 70 individuals, 70 MRIs. So the difference was actually close to the manual telemetry palpation. So it was, the worst case was like 25 millimeters, even on the MRI images. So it's very difficult actually to find these points, especially on the soft tissues. Well, sometimes also in the bone. So we use these landmarks, these control points, and we do more our computational mesh. This algorithm works pretty well. It is based on what's called target basis functions, and there are different, existing functions. We can choose several of them. We're running some tests to see what is actually the best algorithm. But as we will see, these are our first steps. When we go from the asymptomatic nullifier subject to a really pregnant woman, you see that these landmarks can move away, and there's a huge difference. So we did this lately, and the only thing is that we need more landmarks to make sure that the algorithm works and that it fits. These are preliminary results. They will be presented at the 17th National Colloquium in France, of computation structures. So you have the difference here between the initial and the morph model. And we do the same thing now, actually, with the default one, the generic one, and the pregnant subject. So we'll work on this. We quickly understood that there are, there's a lot of challenges, especially with soft tissues. So the major challenges are the individual differences. Even for, healthy asymptomatic subjects, differences are just huge. And they are even bigger when you go from nullifier to pregnant subjects. One of the major, challenge here is the number of landmarks. There are some recommendations how many landmarks you need with respect to the number of mesh nodes, and we are way below this. This is for several reasons. First of all, it's difficult to see those landmarks on the MRI, and then they should also have some anatomical meaning. Right? So it's not really a good way just to put some points somewhere. You have to, they must have some anatomy. So we're trying to figure out if we could possibly extend our set of landmarks using some automatic techniques, like drawing a line between 2 points and cut that line and create more points there, something like that. But for a moment, this procedure is mainly manual. Happily, we do have some task force for this. We do not only have the maternal tissues. Of course, we also have the baby, especially fetal heart. And once again, all three teams use slightly different approaches. So Khalil and Energy, they do also have the experience with hot molding. We at the University of Tasmania just consider the hat as one rigid body, which actually would be like the worst case, right? We expect this would put more stress on the tissue. So we are trying now to combine these actually to have all these options available with molding, bomb molding. That's one of the parameters as well. We have also geometric parameters, the diameters and so on. And this helps us actually to morph also the baby's head. So we can make it bigger, we can make it smaller. And it's not only about the size dimensions, but it's especially about the trajectory. This is about loading. So this is basically about a loading condition. Very difficult thing. There's not a lot of data out there. It's actually only one paper describing the Curtis curve and providing some data on how the head actually goes through and with all the rotations and very complex movement. So we do have these. We do have actually two different techniques, but they are mostly based on the same algorithm, same stuff. So they are once again based on the landmarks, because this trajectory has to be parameterized with respect to the maternal model. So we need to take the landmarks on the pelvis and parameterize this complex trajectory with respect to these landmarks. So in Lille and in Pilsen, we do have these algorithms. We do define, so we do define a plane here going through the baby's head. We have some points here, and this is how we move with it. And this movement is defined with respect to the pelvic planes, the output, the planes in the middle. So very complex trajectory, and it is also parameterized using the already existing landmarks. So this is how we parameterize the geometry of the process. What are loading scenarios? So we did some brainstorming. What do we need to take into account? And we decided to, go through like a normal standard vaginal delivery with occipital anterior orientation, but also occipital posterior. This is something we have previously done. It will work. We'll be able to do it. We included manual perineal protection. And in terms of the instrumental delivery, we'll use our simulations. We will simulate using vacuum extractor and forceps. And we also have episiotomy. So all three teams contributing here actually have already this experience. We'll only need to adapt these models and make them once again parameterized to make sure that they are person specific. And I will conclude with this very short review of the clinically relevant indicators. So this is basically still open question. We have had several working sessions with our clinical partners that we went through. So what are actually the inputs we want to vary? So what are the input parameters we want to vary? And what are actually the outputs we can really measure or assess somehow or compare to the clinical reality? These are very tricky. So yes, we can definitely play with the geometry, we can play with the material properties. This is the parameterization. In terms of fetal head, once again, the geometry and the material properties. And then in terms of the loading conditions, this is these are the intervention parameters corresponding to the scenario we select. And in terms of the outputs, this is still a sort of open question. So what can we really measure in the clinical settings, like some strain, possibly some reaction forces, in terms of on your perineal protection, we can measure the reaction forces of the hand on some instrument development. In terms of the soft tissue damage, this is pending somehow on package 3, working on these conservative models. Possibly some ripple traction, but this is only valid for the instrumental delivery, and there are some other parameters pending for our continuing conversation. So thank you for attention.
Next, we move to Professor Nicolas Satanchamani, who is an assistant professor in the IMT means LS and affiliated with the Euromove Digital Health in Motion Laboratory, where he leads a transverse axis of recovery, variability, and uncertainty. His research interest lies in data mining with applications in health, sports science, and more generally, movement sciences. And he will talk to us today on data integration and signal analysis.
Thank you very much. Thank you, Mona. Thank you, and Sophie, Caro, and Sarah, giving me the great opportunity of being involved in the PELVITRACK project. So I work on data science, so statistics, machine learning. So I'm a bit far from biomechanics, but I'm being educated by Sarah and Sophie. So I heard many things that I'm very interested in today. I think we need to talk a lot, but today I will talk about data, the available data today for the PELVITRACK project, and mainly about evaluation of the models you're setting. So the different criteria, the constitutive model, predictive model, and how should we combine them? How can we combine them in order to make a global prediction for a new pregnant woman about the perineal theory? So at this point, there are many experiments that have been setting in. So we have a lot of data. I use the color code to distinguish time series data and image data. So roughly we have half of time series data, half of image data, which imply sometimes very different modeling techniques. So we have the first part is the standard mechanical test. So stress, vs strain on single tissues. So roughly the PIGS experiment. So in order to characterize the biomechanics of the viscoelasticity and the stress softening behavior of the perineal tissues. So that's for the modeling in the work package 3. But there are many other data, so bioimpedance, colorimetry, thermography, etc., that I think you have different kind of objective when you are modeling. So maybe we should talk about what is a good model. So model evaluation. So the main objective of the PELVITRACK project is to predict perineal failure as early as possible. And that's the tricky point. So what do we mean by as early as possible? I heard about constitutive models. Maybe I don't know, but maybe constitutive models could be used to predict before the birth begins. So in terms of structure, is there a high risk or low risk of rupture? But during the birth, you could predict as early as possible too. And that's another question. So maybe it's another types of model, another types of evaluation. But anyway, we need to establish some evaluation criteria. So some of you talked about it today, Fanny, Baptiste, etc. But I think we should compare our evaluation criteria because we're going to the same direction by different paths. So in my field, the evaluation here can be understood as an anomaly detection problem or a supervised learning problem. So in the first case, we don't know necessarily the outcome. So we just watch different indicators and we react when we find a strange behavior. The second setting is completely different. We have the outcome in the data. So we have different indicators and we know in advance that there are going to be a rupture or not. And we try to predict and we measure the correctness of our prediction. So we need, for the supervised learning, we need to label our data. So that means that for each experiment, you need to know precisely if there was a perineal rupture or not, and if there was, at what time precisely. And that's sometimes complicated. So we need for supervised learning, in order to really being able to evaluate our predictive model, we need some ground truth. Sometimes we can estimate the ground truth by a trick, but it can be complicated. You can estimate it by mechanic indicators or visually, for example, but I'll talk about it tomorrow. You can cross mechanical indicators and visual. So what's an evaluation criteria? So there is a question, how likely does the perineal failure happen? And does it always happen? Does it often happen? And how often can we quantify this? If we can, I think it should be a good idea to integrate this global risk, but I think, and Sophie had some answers about it, we should integrate this probability of rupture into the predictive model. But if we assume that the rupture is very often, so we can assume it will happen, then we face a paradox. I call it the dummy paradox, where the best model is the one that automatically predicts rupture at any time, at the first time. So this would be the best model because he would predict rupture the earliest as possible. But maybe for the cases where there are no rupture, this would be a very bad model. So anyway, we have to take into account the rupture risk, and we can maybe estimate it by the rupture prevalence. Okay, so we have different criteria, and we have a lot of metrics. For each criteria, we can define many metrics. So formally, in the supervised learning perspective, we have a set of examples. So X is multidimensional. It can contain a lot of biomechanical indicators, for instance. And the target variable y is about the rupture. So it can be a binary variable, 1 for rupture, 0 for not. And the aim is to learn a function f theta, or to estimate a parameter theta of a given function, such that the target variable y is exactly the function applied to x. To respond to some presentation of yours, I heard, especially Fanny, that sometimes you're trying to reduce the number of parameters, and I understand why. So when Vit talk about the design of experiments, the more parameters, the more complicated the design will be. So that I understand. But for prediction, maybe you could think the opposite. Maybe if you have a whole set of candidates, some model can manage big sets like this. So we don't necessarily need to reduce the dimensionality of our input variables. So if we assume the rupture is binary, we could use those standard evaluation measures such as accuracy, so the rate of correctness, precision and recall, which are very standard in binary problem in machine learning, or almost equivalent sensitivity, specificity in medicine, in health. So the precision is when you detect, when you predict rupture. So how correct are you? So for all the women who had a rupture, no, for all the women for which you predicted a rupture, were you correct or not? And the recall is for all the women that you should have had detected, have you? So those are two different questions. And usually we give the priority to one or the other, given the context of the experiment. So in the PELVITRACK context, I think recall is more important than precision because it's more dangerous to miss a detection, to miss a rupture detection, than to detect it and it was not a real rupture. So the consequences of a bad detection would be maybe some surgery or nothing. So this is not good. We should avoid surgery for nothing. But maybe it's less dangerous than no surgery when we should have sent the patient to surgery. So maybe we could weight precision and recall through F measure. This is very standard. For example, if we think that bad detection is twice less dangerous than a missed detection, we could give a weight 2 times for the recall, 1 time for precision. This is just an example. We can use the AUC measure, so the area under the curve, which integrate the probability. So when a model, a machine learning model makes a prediction, in fact, it computes the predictive probability and it predicts the highest. But it can be risky to predict something if we are not sure. So the AUC take those predictive probabilities into account. And finally, the design, the temporal design. So I heard that some models of yours are considered sometimes quasi-static, but the giving birth is not static. So maybe for constitutive model, we don't really need to integrate time, but for predictive model, I think we need. But as a first step, we can work with static design. So for example, if you have image data for a given image, is the perineal already broken or not? Sometimes it's not easy. When we see some pictures, some people think that there have been already the start of the rupture, and the others don't. But the other alternative is the chronological design. So we try to predict as early as possible, but maybe not too ambitious. So maybe for the next minutes, will there be a rupture in the next minute, the next 5 minutes, or in the next push-in? It depends what we want. And finally, to combine the model and to decide at the clinical level. So we have mechanical models that provide input parameters that could be used in machine learning models as inputs. So that's my perspective, but I can consider different one. So in machine learning, it's very standard to use different models to combine them different way, so ensemble learning. And in soft computing, we have what we call evidential fusion. So we have different data with different reliability levels, and we use those reliability levels to combine them with some logic, and finally we get a global reliability level. So this could be done in the PELVITRACK project. So I work in uncertainty theories. So there are different uncertainty representations that we could consider. Probabilities is the most standard one, but there are others like fuzzy sets, belief function, which roughly are sets of probability. And when we predict, we could use those uncertainties sometimes to reject prediction if we are not, if the level of uncertainty is too high, we can reject prediction and we don't predict. In some applications, this is done because people don't like to rely totally on model. Thank you very much.
So now we move to the clinical session where we will talk about the challenges and the problems that PELVITRACK is trying to address. And our first speaker of this session is Professor Khalid Ismail, whom you all know as the Managing Director of Supervise Me, but he is also a Professor of Obstetric and Gynecology at Charles University in the Czech Republic and the Rector and Advisor on International Cooperation and Research Grant. He is the Chair of the European Perineal Trauma Group, PEERS, and member of the 4EU+ Academic Council and a consultant for WHO Intrapartum Quality Care Program. And Professor Ismail will tell us about the epidemiology and management of childbirth-related perineal trauma.
Thank you very much, Mona. Thank you very much for such an amazing day, actually. I have like 100 questions in my head I want to ask everybody about. And I guess from a clinical side of things, it's really exciting to see what you're trying to develop, because at the end of the day, it's us clinicians who are going to use it in real life. So thank you so much for that. Also, thank you for asking me to give this talk today. I know my participation in PELVITRACK is in a different context. However, this topic is very close to my heart. And I'm going to talk about perineal trauma and pelvic floor disorders. Of course, there are many pelvic floor disorders. In this talk, I'm going to focus on urinary incontinence, anal incontinence, perineal trauma in general, also skin sphincter injuries, as well as levator avulsion. So when it comes to childbirth and pelvic floor disorders, and many times I say this at the beginning of my talks, and I hope it's not taken out of the correct context, but I would say if perineal trauma at the time of childbirth was a man problem, either it would have been sorted or we would have been extinct. But the fact that we still have this as a problem is just because women seem to accept and agree to go with lots and lots of problems, or maybe they don't talk about it. So more than half of the women who have a vaginal birth will experience some degree of suture. And also, in a study done in the United Kingdom over a 12-year period from 2000 to 2012, it seemed actually that things are getting worse. So the oasis rate was going up. Of course, many people said it's probably linked to improved diagnosis, clinical diagnosis. However, it's still a problem. 1 in 3 women after a birth will be incontinent for urine. And also a significant number of women will have levator avulsion, which is really quite a significant trauma that happens to the deep muscles of the pelvic floor. And this is strongly associated with pelvic organ prolapse. So before going on and talking about all these things, let me present you some data from a study called the PROLONG study. It's not one of our studies, but it is the biggest study that recruited patients at the time of a birth and followed them up for a period of 6 and 12 years, mainly focused on pelvic floor disorders. And this was done in 3 different centers in 3 different countries, England, Scotland, and New Zealand. And the PROLONG study, which has recruited almost 8,000 women, has shown that 3 months after the first delivery, a third of these patients had urinary incontinence. And when they followed them over a 12-year period, the problem seemed to be getting worse. With anal incontinence, of course, the risk of that is much lower, but it is a more significant problem. And again, almost 10% of women, 1 in 10, will have anal incontinence after birth, either incontinence to flatus or to feces. And this problem is going to get worse over time. And this is any birth. I'm not talking about vaginal birth. If we start looking at these births in the PROLONG study by mode of birth using spontaneous vaginal delivery, somebody who just went in, had a baby, no problem whatsoever, except maybe an episiotomy, and using this as a reference, it seemed when they followed up these women over a period of time, and some of them would have had certainly more than 1 child, some of them vaginally, some of them by cesarean section, they found that women who only had spontaneous vaginal delivery, the risk of these problems I talked about was the same as women who had a combination of both. So somebody had a vaginal delivery and decided this is too much for me, I want to have cesarean sections, what the problem has happened. Or somebody who had a cesarean section and thought, well, actually, I would like to try vaginal delivery. So the risk then became the same. And even women who had an instrumental delivery, this did not increase these risks of pelvic floor disorders. They were also able to look at fecal incontinence, and interestingly, the same thing with fecal incontinence, whether somebody had a spontaneous vaginal delivery or cesarean and vaginal, it did not matter when it came to the risk of anal incontinence. Of course, if somebody has had a forceps, however, the risk of anal incontinence was significantly higher. And they also looked at parity. And it seems if you have 1, 2, or 3 children, the risk stays the same. Once you start having 4 or more children, the risk of pelvic floor disorders becomes much higher. What about levator avulsion? Levator avulsion is something that is really quite topical. We talk about it a lot. We know very little about it. We know it's linked to pelvic organ prolapse and other forms of vaginal wall prolapse. However, there is very wide variation in the reported incidence of levator avulsion. There is also wide variation in how we diagnose it, whether we use MRI or scan. When do we diagnose it? Immediately after delivery, after a few weeks, after a few months. And this actually triggered us to conduct quite a large systematic review. Our group conducted that. And we've demonstrated, without going into details of lots of forest plots, that the risk of levator avulsion after a spontaneous vaginal delivery is 1 in 6, 15% of women who have a very easy normal vaginal delivery will end up with a levator avulsion. They don't know about it. We don't know about it because it's hidden. What about if somebody has a vacuum extraction of one tubes? The risk is 21%. What about if somebody has a forceps? The risk is 52%. 1 in 2 women having a forceps will have an avulsion. How many women actually know this information? However, it's not all doom and gloom. And this is a study, the FINESSE study was a study conducted with our colleagues in the University of West Bohemia, just looking at when actually would an avulsion happen using computer modeling. And it seems that the avulsion happens when the head is fairly low at station +9. +9, the vertex is visible in front of you. So there maybe is hope in what you are trying to develop. PELVITRACK, a tool that can predict the tension on tissues so that you can do something about it at this very late stage in delivery. Maybe you can also reduce the risk of the hidden harm on beta. So my first conclusion for the talk is that the largest impact to the pelvic floor happens at the time of the first vaginal delivery, whether it's the first delivery or the second delivery, if somebody has had a cesarean section before. Of course, these symptoms will get worse over time, and parity does not seem to have a significant impact, except if somebody decides to have 4 or more children. Levator avulsion is more common than expected, and also it seems to happen at the time of head expulsion, not before that. So moving on to the pelvic floor, for simplistic reasons, when we talk about the anatomy, we have superficial muscles, what we term perineal muscles. We have deeper muscles, the levator ani, with all its parts, and some connective tissue holding these structures in between. However, it's important to emphasize that the external anal sphincter is a superficial perineal muscle. So you don't need a very big, deep tear for it to be an oasis. It could be the smallest tear of all, and it is reaching the external anal sphincter. And this is something we spend a lot of time on in our training to make sure that doctors and midwives are aware of this. And we also highlight the fact that the internal anal sphincter and the external anal sphincter are complementary organs. They are opposites. They have a yin-yang relationship. The internal anal sphincter is a pale tissue, smooth muscle under involuntary control. In the static state, it is contracted. The external anal sphincter is a striated muscle. It's red in color. It's under voluntary control. And in the resting state, it is relaxed. That's why, if you have a problem in one of these, the symptoms will be totally different. So don't expect the donor is just going to come and complain of incontinence. It will be much more complex than this. Of course, this is the classification of perineal trauma. And in this classification, we talk about first-degree tear, just the skin of the perineum or the vaginal mucosa, second-degree tear involving the perineal muscles, but not the anal sphincter complex. And then third and fourth-degree tear are those involving anal sphincter complex. My only issue with this classification is that it makes it sound as if the tear becomes bigger and bigger and bigger. Well, actually, you can have a very big second-degree tear and a very small third-degree. So put this in mind when it comes to assessing the problem. We can't talk about perineal trauma without mentioning episiotomy. Episiotomy in the past has been practiced quite routinely in lots of countries. Now, very few countries do this, but these few countries deliver a lot of people, like the Middle East and many countries in the Far East. They still do routine episiotomies. In these countries, it is considered to be the second most common surgical procedure ever done in medicine in their country. The first, of course, being cutting the umbilical cord, which is something we also do. So episiotomy is a second-degree perineal tear. And it's always an interesting question when you ask people who practice lots of episiotomy, what are you trying to do? And they say, we're trying to reduce the risk of tear. I say, okay, what type of tear? And they say, well, we say, it can't be second-degree tear because you are creating a second-degree tear. You can't really do a second-degree tear to reduce the risk of second-degree. And they say, oh, of course not, it's third-degree. And then we say, okay, so what's the risk of third-degree tear? And many people actually can't give you a figure. And almost everybody does not know their local figure in the hospital. It's not something that they look at. And even when they say it, they don't report it. But even episiotomy, which is a very, very common procedure, it's the first thing we do in our training as obstetricians, and certainly probably the most important thing that midwives, or some of the midwives, might do. However, episiotomy is actually not one procedure, it's many procedures. If you have your baby in France or in the UK and you're going to have an episiotomy, it's a right mediolateral episiotomy. If you have it in the Netherlands, it's a left mediolateral episiotomy. If you have it in America or Canada, it's a midline episiotomy. If you have it in Finland, it's a right lateral episiotomy. If you have it in Norway, it's the left lateral episiotomy. I think Spain is right mediolateral as well. Is this correct? But the other important thing is what people cut. is not actually what they wanted to cut. It sounds crazy, but I know everything is based on the intentions, but not when it comes to episiotomy. Because if you're cutting an episiotomy and saying, I'm cutting a right unilateral episiotomy, similar to this study in the UK, practicing obstetricians and midwives, 100 of them, we asked them to cut an episiotomy on this episiotomy cutting model, the treating model at that time. The good thing about it is you can peel off the perineum and measure the angle of the episiotomy they've cut. And luckily, all of them have cut an episiotomy on the right-hand side, so at least they knew the right from left. But when it came to the parameters of a medial lateral episiotomy, only 12% of these episiotomies were correct. The majority, 88% of these episiotomies, either did not start at the midpoint, so they were not medial lateral in the first place, they were lateral episiotomies, or they subtended an angle less than we took 45 degrees as a cutting point, it should be 60, but less than 45. You know that if you cut an episiotomy at an angle less than 45, you're increasing the risk for the woman having an oasis. So that's why the Cochrane recommendation is that we should adopt a selective episiotomy policy, and this is something that PelviTrack might be able to help with, because the difficulty we have as clinicians is, okay, I want to be selective, but who to select? So maybe PelviTrack is going to help with this. It's also important to make sure that you don't exaggerate the evidence. So don't extrapolate the evidence, don't exaggerate the evidence. Being selective does not mean not doing it at all, because this is what happened here in this set of data of about 85,000 women from Denmark. They reduced their episiotomy rate from 60%, which is far too high, to below 5%. And look at what happened to the oasis rate. It starts going up. So don't restrict your policy, but just be selective. We also, when it comes to the management, we know the best way to repair an episiotomy, and the evidence is fairly strong there. It's that strong that the Cochrane collaboration itself have stopped adding evidence to it, because the evidence is so strong that there is no point in wasting time. I was fortunate enough to be involved in both these systematic reviews and their iterations. And actually, when you adopt this policy, and this is a national quality improvement project that we have undertaken in the UK in 22 units with quite a big collaborative group of obstetricians and midwives. And we've demonstrated that if you follow this technique of repair, you can reduce the risk of wound infection and wound complications for women. So taking you back to this classification, but now I'm going to focus on obstetric anal sphincter injuries. And of course, oasis encompasses both third and fourth degree tears. These are the risk factors for an oasis. It's really very unlikely you will have a patient you're looking after that does not have any of these risk factors. And that's why throughout our training and practice, our focus has always been on recognition. We really did not have, and also on intervention to reduce the risk, which my dear friend and colleague, Dr. Margarita Manresa, is going to talk about in a minute. But recognition was one big thing for us. And how do you recognize the trauma? You can do something basic, and a lot of our training is in areas that really don't have necessarily access to scanning machines and imaging techniques, and they also don't have the expertise really to be able to make a diagnosis, knowing that diagnosis is far more difficult immediately after birth because the tissues are swollen, they're edematous, there's a lot of blood, there's already a tear there, it's quite difficult to see through with a scan machine. So we train people to do the pill rolling movement, a very simple movement that you do, not necessarily a proper parectal examination, but a way of just assessing the external anal sphincter, making sure it is intact with the sphincter rolling between your fingers. And it's something that we spend a lot of time in our peers training to make sure clinicians are aware of it. Of course, if you have access to technologies, then by all means do an endoanal scan, a 3D endoanal scan, a transperineal scan, a tomographic ultrasound scan, whatever you want to do. And this will also help you in the diagnosis. It's something we use a lot of in follow-up later on. People spend a lot of time when it comes to repair. I told you repair of episiotomy is sorted, at least evidence-wise, it seems at the moment, unless if something totally unexpected happens. With external anal sphincter, there is a lot of debate whether we should do end-to-end or overlap. And actually, to be honest, there have been really quite a few clinical trials, and when you do the systematic review, you can see from this forest plot, it really doesn't matter what you do. Just diagnose the tear and repair it properly. It doesn't matter whether you end-to-end or overlap it, but people seem to leave all the debates in the world and keep debating their points, which, fine, if you have sorted everything else, like prediction, which I guess is the most important one, then do that. So the extended anal sphincter, overlap or end-to-end, it also only applies when the extended anal sphincter is totally torn. So if it's partly torn, if it's a 3B, but still some fibers are intact, you can't do anything except end-to-end repair. IAS is always, the internal sphincter is always end-to-end, and the aneurysm, because it could be continuous or interrupted. Oasis does not only have an impact on the woman there and then, or on her problems at the short or longer term from the bowel function point of view, but it also has a significant impact on her future mode of birth. So if a woman has had an obstetric anal sphincter injury that has been repaired, she's asymptomatic, and her ultrasound scans are fine, and she continues to be asymptomatic, they can be offered another vaginal delivery. However, if they are symptomatic or have any abnormality on scan, and there are very strict criteria for abnormal scans, then they should be offered elective cesarean section. There is no evidence that a prophylactic episiotomy has any place at that time, and women should be made aware that their risk of having a recurrent oasis is higher than somebody who did not have an oasis before. We've been talking about prediction models, and I must say, Nicola, I loved your talk and how you are dealing with uncertainties, because certainly we are in a situation which is totally uncertain when it comes to clinical practice. So I'm sure we will make use of your expertise a lot. But this is a prediction model. It's a very basic one, and I do apologize to you for that, because obviously dealing with much more complex data. It only involved 85,000 women, and it was done as part of our work with Aarhus University in Denmark, and we only used clinical parameters using their database. But this point is really interesting. This is actually a screenshot from the calculator. We don't use the calculator clinically because it's not properly validated. And as you quite rightly said, what happens actually if you tell somebody you are going to have an oasis and they don't have it? Or indeed, if you tell somebody you're not going to have an oasis and they have it, and we don't have this information. But this is, let's assume, for argument's sake, we've put in this calculator that this patient is 20 years old, she's having her fourth baby, okay? And the baby's head is in the Oxford anterior position. She's only 38 weeks. It's a good size baby for her. She pushed the baby out in under 30 minutes. So what's her risk of having an oasis? It's low. But how low is low? Well, her risk is about 7,000. So you really don't need an obstetrician or a midwife to be even in the room. But let's just change some of the parameters. So this woman is now 42, and she's having her first baby. And the baby is in Oxford posterior position, but the baby's weight is fine for her. And it has taken her a little bit longer to push the baby out, but still push the baby out within 1 hour. What's her risk of having an oasis? Well, it is higher than the first one, but how much higher? And her risk is about 10%. Then let's change the scenario a little bit more and say, well, actually, this woman is 42 weeks. This baby is a little bit big for her. So we suspect there is macrosomia, and she needs actually a lift out. She needs an instrumental delivery. She's exhausted. Help me, please. And then somebody goes into the room and say, oh, I can see the head, just needs a lift out vacuum. I'm just going to do this in the room. Don't need to do an episiotomy or anything. The head is just there. I'll do it very slowly, no problem. But then if this person came back to their senses and decided, well, actually, this is an operative vaginal delivery, I need to cut an episiotomy, I need to cut it correctly, then you can reduce the risk for this woman back to almost the risk before. So my second and last conclusion for the talk is that we have very strong evidence for diagnosis and for repair techniques, whether it's second or third degree tear. However, we do not have anything when it comes to, we don't have an objective tool that helps us to prevent trauma. And this is where PELVITRACK actually hopefully can kick in to let us know objectively what I need to do to prevent the trauma, or if there is nothing there to prevent it, then maybe I should take another action. And of course, the biggest impact on the perineum and the pelvic floor happens because of our decisions at the time of birth, obstetricians and midwives, and sometimes the patients themselves. I can't finish off without acknowledging a few things you've heard about PEERS. PEERS is a not-for-profit group that was set up in 2012. Marga, of course, is a PEERS member, and of course, Renaud de Tarac. And since 2011, we have been involved in a lot of training in different countries, in every single continent, all over the planet, some of them more than once, which is reassuring when people ask me to come back again. And our training is multi-professional. Of course, many of the slides are presented today as part of our workshops. I've also been involved with the WHO for a few years now. It started in 2015, and it's carrying on up to now, in delivering the training as part of perineal trauma. But also, I have been leading on a program called, it's about quality intrapartum care, and of course, perineal trauma constitutes a big part of that. And I'm also involved with the 4EU Plus for their training program, and the 4EU Plus is an EU alliance that involves 8 universities. And I just had to acknowledge these organizations because some of the slides are obviously used in these platforms as well. They are mine. I didn't borrow any slides from anybody, but they're used in different contexts. Thank you very much.
Thank you. Last but not least, I would like to introduce Dr. Margarita Memreta, who is a midwife in the Hospital Clínic de Barcelona, and she specialized in prevention and treatment of perineal trauma and pelvic floor dysfunction during pregnancy, birth, and postpartum. She's completed her PhD in 2020, which was focused on pain and dyspareunia related to pelvic floor muscle injury after vaginal birth, and she is a specialist midwife trained in the UK and set up the first and currently the largest perineal clinic in Spain. Marga is a member of the PEERS group, as we've mentioned, and the inventor and patent holder of Pelvic Plus, an interactive pelvic anatomy simulation model. And she will tell us about interventions to reduce the risk of perineal trauma.
Thank you, Mona, and thank you for inviting me to give this talk. It's something that with all of the midwives and clinicians who attend birth try to do in order to avoid or prevent from perineal tears, but not only from perineal tears, because we try to avoid all the problems that Professor Ismaili has spoken in this last talk. So our objective is prevention of perineal injury, but is prevention from all these diseases, the reduced risk of perineal pain, reduced risk of dyspareunia, reduced risk of anal incontinence, urine incontinence, and all sexual dysfunctions. Okay, so the intervention to reduce risk of perineal trauma, we recommend interventions during pregnancy and others during during birth. Okay, during pregnancy, I'm going to introduce you the recommendations published and how we apply these recommendations. During pregnancy, we have 3 main interventions: pelvic floor muscle training, antenatal perineal massage, and
vaginal devices. Related to, in terms of pelvic floor exercises, there is no strong evidence related to reduce perineal trauma, but is a high evidence for avoid urine incontinence. So it can reduce the risk of urine incontinence during pregnancy and in the postpartum period, in the intensity of this urine incontinence, and it decreases the risk of severe perineal tears, so BOACs, and shorten the second stage of labor. Okay, and the recommendation so that we give to women is to start pelvic floor exercises as soon as possible during pregnancy. If it doesn't exist urine incontinence, it will probably reduce the risk of incontinence in the third trimester of the pregnancy and in the postpartum period. But if it exists, we recommend to do pelvic floor exercises as well, at least 4 or 5 sessions per week and at least 6 weeks. And it's better individualized. The health care professional could test or assess the pelvic floor and how they perform pelvic floor exercises and give some recommendations about how many slow contractions or quick contractions has to do each pregnant woman. Related to antenatal perineal massage, it has a big recommendation, and they increase intact perineum in primiparous women and older than 30 years old. It's the highest recommendation. Decreases OACs, decreases episiotomy, decrease perineal pain, improve perineal healing, the healing in the postpartum period, and decreases the duration of the second stage of labor. Apart from that, the feeling of the pregnant women who have performed antenatal perineal massage are higher, or they perceive they perceive this intervention as they have more confidence when they have to face birth, and if the partner is involved, they feel that they are very close to him. And which other recommendation in terms of the technique and how often they have to repeat this intervention. As I said, we focus this recommendation is to all pregnant women, but especially those who are primiparous and older than 30 years old. We use as a lubricant water soluble gel or olive oil or sweet almond oil, and we recommend in those women who has a very tight perineum to have a bath or apply warm compresses before to the perineum prior to the massage, and we recommend to insert one or two fingers 3-5 centimeters inside the vagina and apply a pressure downwards and lateral, and afterwards to start with a U-shaped motion from side to side. It can start earlier, but we recommend to start from 34 weeks onwards and at least for 5 days per week and during 5 minutes. Okay, well, I recommend every day because they will perform at least 4 or 5 days per week. It's better in order to increase adherence to the antenatal perineal massage. It's better that a professional perform the first session and could give some follow-up in order to resolve some problems or questions, and if written information is provided, it's better for increased adherence. There are some contraindications, vaginal herpes, thrush, urinary infection, or in case that there is a vulvar varices, we have to individualize care for recommendation. And in the third strategies or intervention during pregnancy could be these vaginal devices. However, until now, there is no difference between do perineal massage or introduce or use these kind of devices. Small studies have shown that there are more or intact perineums or minor perineal tears. So these devices are Pino and the Pino and the Anibol, and it introduces, it inflates the vaginal balloon device inside the vagina from 36 weeks on pregnancy, and gradually stretches the vagina, the perineum. So during birth, the strategies that or the intervention that we recommend, first of all, is manual perineal protection. Manual perineal protection, when we have to attend childbirth, we have two kinds of approaches. We can touch the perineum or not touch the perineum. If we touch the perineum, we know as hands-on, and if we don't touch the perineum, it's called hands off, or we recognize as hands off. Hands poise is if you feel that the fetal head is going out very quick, so you only it's only allowed to touch the head but not the perineum. So based on these two approaches, there are so many studies and systematic reviews that try to understand which of the approaches are best in order to reduce perineal trauma. So systematic review that only include randomized control trials, they don't find any differences in terms of reducing oasis. But when cohort studies are included in the systematic reviews, there is the conclusion is that there is a reduction or prevention from oasis when hands on is applied. Okay. However, other studies that has been because it's very difficult to only measure one intervention, and they have in several countries they have introduced some care bundles in order to reduce the oasis rates. So these care bundles introduce several components such as control or keep confident or increase the confidence during birth with the woman, try to do manual perineal protection. So, and these are the results of this last study, which they compare the data that they had before and after to implement the care bundle in Norway. So, as you can see, the rate in women that had no previous OASI, the rate of oasis decreases 62% when manual perineal protection has a manual perineal protection approach. Okay, and in those women who had an ascitea, an oasis in the previous birth, the chance to have another oasis gets reduced with 51%. And the conclusion of this study was episiotomy and epidural analgesia, birth of no other components has been changed in the in all this time. However, and so this is why they concluded that this reduction is likely was likely explained by the implementation of manual perineal protection as part of the national care bundle in Norway. Okay, so based on this conclusion, I'm going to show you which are the two approaches, the two maneuvers that aim to reduce the stress of the perineum during the fetal head expulsion. They try to reduce this axis, the transverse vector of the stress of the perineal fibers. And the program, or all the components of this program that the care bundle had included, was communicate with the women because they want, because we need to control the fetal head or the baby's the fetal birth. So during all the process of the birth, you try to gain or build this trust. Because when it's the time that the fetal head is in the perineum, the woman the pregnant woman feel a very high burn and pain, and she has to control this push. Okay, so during birth, it's necessary to gain or to build this trust. Manual perineal support. Maternal position which allow a visualization and to do manual perineal protection. If necessary, to do an episiotomy at 60 degrees, and afterwards to do a perineal assessment. Okay, so and this the Finnish maneuver and the modified Viennese maneuver are the two only maneuvers that reduces this axis or the transversal axis of the perineal stress. Okay, so I'm going to try to show you how we perform this, or it is described this maneuver. So when the vaginal opening is open more than 5 centimeters, more or less, or when the tissue are stretched, we apply with our dominant hand. We apply the thumb and the index fingers, approximately 11 or 12 centimeters at both parts of the vagina. Okay, and try to reduce this main vector of tension. Okay, and when the fetal head, with a non-dominant hand, we control the speed of the extraction and the deflection of the fetal head. Okay, in the step 4, once the chin, with the dominant hand, once the chin is at the level of the anus, we extract the chin in between contractions. And at the end, with the dominant hand, we reduce this main axis when we have to extract the posterior shoulder and all the babies, all the fetus. So, at the second intervention during birth, in order to reduce perineal trauma, is intrapartum perineal massage. There is no it's very low or moderate evidence, and it increases the evidence when it is associated with when applied warm compresses. Okay, so the benefits of performing intrapartum perineal massage is reduction of severe perineal thrombolysis and lower the episiotomy rate. We normally use 1 milliliter sterile lubricant, and with gentle is similar to the antenatal perineal massage, and but we adjust the pressure according to the participant feedback. If the woman has a epidural, it's different, but if not, it could produce pain. And normally, if they don't ask for a epidural, for anesthesia, they don't prefer, they avoid. Well, we avoid to tie epidural during the birth. Okay. And the intrapartum perineal massage should be applied in the second stage of labor and for at least 10 minutes. Warm purposes is a high evidence or moderate certainty evidence, and is a moderate recommendation. And we apply this, but the benefit is the same as the intrapartum perineal massage. They reduce perineal trauma and lower episiotomy rate. And I'm sorry. Sorry. Wow, it's the same. Sorry, I missed this. So the temperature is about 40 degrees. It's not longer, but if the pregnant woman has anesthesia, the temperature has not to be increased. But if she doesn't ask for anesthesia, we can increase the temperature, and you should apply it at least for 15 minutes. And you can apply it between contractions or during contractions or when she is pushing. It depends, because literature doesn't specify when is better or not. And during the second stage of labor, normally when they are pushing, and at least for 15 minutes. And the last, maternal position. Well, maternal position is very difficult to conclude something. Which is the best maternal position in order to avoid or to reduce risk of perineal tear. Okay, and some of them, it's very, the last systematic review that has been, I think that the Spanish group has published, said that there is no, the conclusion was that all the conclusions had to be taken with caution, because it was difficult to conclude something, but they summarized some positions. That left lateral position said that decreases the vulvar edema and fewer episiotomies. Semi-setting position was low, decreases the risk of first perineal degrees, but increases the second degrees and episiotomy. Standing position lowers the risk for first degree perineal tear, and squatting position lowers the risk for second and third and fourth degree tears. Hands and knees low risk for episiotomy, and whatever, that is another study, the full study, showed that it was better to give birth in the pool than outside. However, the numbers of inside the pool for nulliparous and also for multiparous women was very high. So very high inside the pool was higher than our numbers outside the pool. So when we give a recommendation to our pregnant women, we individualize in our hospital, which is our rate inside the rate outside, our rate outside compared to the rate inside the pool, which is higher than outside. well, the reason is because inside the hole we can't perform perineal protection, and outside we always, at least at my hospital, we always perform manual perineal protection. So the conclusion would be that any maternal position that allows adequate visualization and protects the perineum will reduce the risk of perineal trauma. Okay. And the last intervention that we recommend is episiotomy, or we talk with the pregnant women about to include or not in the birth plan, because episiotomy here, at least in Spain, is something that all pregnant women try to avoid, and it's something that they understand as a obstetrical violence, and we have to be very or talk with very caution, because it's a problem for us sometimes. But we say that we tell them that if the episiotomy is well performed and the attendant consider this good for her, it's a beneficial for her to do an episiotomy, and it's well performed, the risk of suffering from suffering oasis decreases. And if they suffer, because they suffer from oasis, they will suffer from anal incontinence, which is worse than pain or food. So, which is the correct episiotomy? So, Professor Ismail talked about this. It's a mediolateral or lateral episiotomy. It should be performed at 60 degrees, and each 6 degrees that that deviation from the middle line is associated with a 50% reduction in risk of oasis. So, if the episiotomy could be, there are only 2 positions. It could be a prevention from oasis, or is a risk factor for oasis. So it should be performed at the time of the crowning, at length more or less of 4 centimeters, but it has to cut the bulbocavernous, the superficial perineal muscles, and the depth at least 1 or 2 centimeters into bulbocavernosus and transverse, superficial transverse perineal muscle. Okay, so to conclude, the interventions to reduce risk of perineal trauma during pregnancy, which we recommend the most is antenatal perineal massage from 34 weeks onwards at 2 pruniparous women and older than older than 13 years old. Okay, pelvic floor massage training in order to reduce risk of urinary incontinence and start as soon as possible, and vaginal devices. Okay, until now, normally if they don't want to, or they have some criteria because that they don't want to perform antenatal perineal massage, so we recommend a vaginal device. And during birth, the strongest recommendation is manual perineal support. The most important is the most important component, and to perform Finnish maneuver and or modified BMS maneuver. The communication in order to build trust, and slow extraction of the fetal head and the shoulders. Warm compresses between 38 and 44 degrees. Higher, it could be higher if with no epidural, and we have to remove some to maintain the warmth, and at least for 15 minutes. Episiotomy, selective, mediolateral or lateral, at 60 degrees, straight at 8. Okay. And maternal position, we conclude that any maternal position that allows adequate visualization and protect the perineum, and intrapartum perineal massage, better in combination with warm compresses. Okay, thank you.
So thank you very much for everybody sticking to time. I think we have decided to leave the questions and answers till the end. So actually, officially, now the floor is open for questions. What I'm not sure about, and I need to be a little bit diplomatic about it and take your opinion and votes about it. Do you think the speakers would all come and sit here on chairs and we can all ask questions and they answer so that whoever is joining online can see them? Or ask questions and whoever's going to answer is going to come and stand here and answer and then go back again. Just there'll be a lot of activity there. But anyway, it's entirely up to you. Or of course you can answer where you are, but probably people who are joining on YouTube will just listen and not see anything.
Maybe we can move the camera. Is it easy to
This is a fourth option. I like that, Sarah. I'll do that. And is everybody happy to appear online? Yeah. Maybe we can have the lights on or something. So shall we start? Does anybody have any questions about any of the sessions at the moment? Thank you very much. This is great. I can start by asking a question if you don't mind. Maybe some of my questions will cross boundaries between speakers because obviously the lines of demarcation were not always very clear between talks. That we talked, I think it was yourself, Luca, when you were reviewing the different possibilities, and one of them was colorimetric methods to assess color. Was it yourself or Baptiste? Sorry?
No, colorimetric.
Yeah, to look at the changing color of the skin. And my question was, would the color of the skin have any impact on the sensitivity of this method? So if somebody has dark skin or somebody has light skin, if we're trying to see the whitening of tissues, would the original color of the tissue affect that test potentially?
Well, I'm not an expert in the field. It's a work by EPFL, but I assume that there is a normalization. So you study only the differential colors. Indeed, one of the metrics was the difference in color. So I hope that this important point was compensated.
Yes, I think that you have a reference picture, and it's the evolution of this picture along the stretching in comparison with the reference one. That is important. And they also look after the texture, so color and texture. So, always in comparison of the
to the original.
Yes.
So there is an inclination, I believe, that to see something which is more black. Well, it depends on also the design of the skin.
I mean, it sounds really interesting because I guess clinically you can see by clinical sense that the tissue is about to tear. Part of it is thinning and the change in color, as you said. But it's if it's going to be used as a test, I wasn't sure of the impact of the original color of the skin. This is very
yeah, just a remark on the question. I think it's important. Internationally, we know that for face detection, face recognition, most models were trained on white veins that are not efficient for black people or women. So if we select on the patient selection, maybe we should be careful.
Okay, for the clinical trial, there is no restriction on considering the color. So maybe it will be an issue.
We have seen in for example, in the illustration shown by Baptiste from the paper Vladimir Kalis, when they did the solar photogrammetry on the childbirth. In this picture, actually, we see that the tear starts from the anus, seems to start from the anus, it doesn't reach the vagina yet. How often is that? Because in our study in PELVITRACK, we mostly consider the most common case, I guess, from the tear goes from vagina mucosa and then reaches all the tissue until the anus. How wrong are we not considering really tearing starting from anus and also tearing from inside that we cannot see? What's your opinion on that, clinicians? Is it really normal?
How often? Well, I think that the fistula or a tear in the anus filter, and when the perineum is intact, could happen, but it's very rare. And normally the tissues, the tear started in the mucosa, and afterwards to the perineal muscle, and to be in the lateral as well, and sometimes this is in this organ.
Yes, from my point of view, I agree also with Marga. From a clinical point of view, it is very unlikely to have somebody who has a tear in the anus and the upper part of the perineum and the vagina are intact. So in most of the situations, we would have a tear either in the vagina and perineum, or vagina, perineum, and anus. The question is, when the tear actually happened, before it cut through everything, if it's going to extend to the anus, whether in that situation it started in the anus or at the top, is difficult to tell because everything happens very quickly. And I would have thought, given that we could only have a first degree or a second degree or a third degree reaching the anus sphincter, that probably it's the other way around, but it's an interesting point. And as Marga said, occasionally we have what we call a buttonhole tear in the rectum, for example, and probably a tear in the vagina, but the perineum is intact. But these are really less likely situations, and they are more commonly associated with some types of operative vaginal delivery rather than a spontaneous tear.
Well, I had a comment, question, and a proposal at the same time. So I like your presentation about this method of supporting with the end during the delivery. And I was thinking about the possibility of developing a device, an elastic device, providing some force. And as we talk about the importance of making a simulation which is adapted to the subject, maybe the expert in simulations could provide some simulation adapted to the subject of this device and see what we can do in order to prevent that there is a strong stress focus in a certain position.
Only worked a lot on this.
There's some projects, and one of them, I think that there was like a silicone that they place on the vagina and try, but they don't. Yes,
It's nothing to do with the manual.
Yeah, and there is another one. It's public. It's not nothing confidential, but I think in California, or I don't know where in the United States, there's a group that are trying to develop a device that could reduce the main axis, the main vector, and this is where started.
But this is the fixed, not adapted to the.
No, well,
This could be
I don't know, they contacted me because they wanted to ask me some questions, but not confidential. Some questions, and this is why they send me some papers that for some research that they had presented for in order to find funding. And so I can't remember, I don't know in which moment they are in this moment of this. But I don't know, I was thinking about it, and I think it's difficult because the maternal position, it depends on the maternal position, it depends on the maternal size, it depends on the BMI, I don't know. It's not.
I think certainly, I think certainly it's not easy. Otherwise, it would have been done. The fact that it's not there is an indication that it's complex. But also going back to Sophie's comment about the next project. Actually, if there is ever a device, it would be nice to be integrated with PELVITRACK, because at least you can have something that is trying to reduce the risk, but the PELVITRACK says this is not enough, and we need to do something more. And this is the reality of the situation, because you are, as a clinical person, assessing all these things all the time. The problem is you don't have anything objective. So in many countries now, we have many legal problems that people will come back and say, why did you cut an episode? And all what you're guided by is, my gut feeling or my clinical sense. But you can't really have this as evidence. So maybe it would be great actually if you start thinking of this and potentially, if it ever materializes, that it would integrate or talk to.
And God, we worked a lot on this together with a lot of our colleagues from the same hospital, from the same place. He told us stories. So sometimes he had to push so hard that he was unable to send the paper down. This can actually lead to the injuries of the obstetrician himself. And we measure the forces going through actually the body between also to start a model of the obstetrician. And depending on the height of the table, the position, you can even hurt yourself. The forces going through the vertebra are so high. So you need to really take a good position, and this technique might not be actually electable for everyone. And our folks from OTH Institute developed a virtual reality training tool for obstetricians, how to actually take a position, the right position. So that's a teaching tool for the obstetricians. I can hardly imagine the tool doing this itself. The forces, and we measure the forces, so we have like the instrumented block. Now we measure the pressure and the obstruction with some force points, so mock-up system registering recording all the movements and the reaction forces and so on. So we have some estimate. It's tremendous.
There is a group also in France that look after the position of the consequences of the position of the precision onto the theory when they use instruments. Yes, it's important.
And this is, I was not aware of this, but this is really very important, because when you see sometimes how people actually are exaggerating all the moves as part of delivery, you're not really surprised that that has happened. So it was not the patient or the baby, it was actually just the actions themselves. So it's really interesting. Yes.
Sometimes in our hospital, we have, for instance, small babies, but very quick. And
so you have to manage the push and the duration and the intensity.
And this is really a big part of the manual Perineal support, to be able to communicate with the patient. I wanted to ask, if I may, actually, I'll take the privilege that I'm coordinating to ask two questions. But the other question actually is probably covers most of your talks, and it's about the modeling. I know that obviously you are including lots of amazing parameters. I love your equations, and it makes me believe that we can generate something really good if we have that complex equations in the background. But do you see eventually that the prediction model used for PELVITRACK, that it will also incorporate patient characteristics as well as all the other tissue parameters, going back to this point about personalized medicine? Because I showed you from the pure clinical model we had, you can actually change the risk significantly just by the clinical parameters. So I wonder actually if this is going to happen as part of this, maybe the clinical studies, or this is something for the future, or maybe you don't need to think through this at all.
Actually, Khalid, maybe the good thing is to use your simulator, the one you showed, so that you have the first risk estimation based on general parameters in the patient that we can have, and then complete that with the data that we have with the device and the mechanical information that we have. You merge these simulators.
Yes, I mean it's a possibility. I think whatever we do, whether there's an existing database or a new database or this database or add to it, of course this database belongs to all those universities. We have to go back to them for us to use it again. But it's I think it's something that is really worth incorporating once we have a working model, because this can improve the predictability.
With recent advances of ultrasound G-ray elastography, we might possibly have access to some data, even though these mechanical modules are more like a tangent modules, so they more user for comparison, but these are not the absolute values. But today, there has been tremendous progress in these technologies, and they can not only inform about like the elasticity module, but also today even the disability modules. And there are some data post-processing techniques being developed even for very tiny thin membranes, where usually these devices only to provide some noise. So this is something I expect to develop in the near future. We are trying to work on this, that we should get actually this acquisition with it's an active because of all these internal processes and so on. We hope to have this, and we will try to explore this technology. This might be one of the pieces of the puzzle.
An idea of the project also is to follow women during pregnancy. So for all women, we will have some reference value that depends on a lot of things, the age, the tissue themselves. So we have some mechanical value, for example, by implantation. And we follow the evolution of this parameter during the pregnancy and during the delivery. And this value will be completed by the modeling. So I think that we will reduce the variability, like we will reduce it on PIT, on PID also. So it's a combination of all measurements, in fact.
The complementary answer is that we need at some point to tackle this within PELVITRACK, because remember that all the characterization is done on a porcine tissue, and so we need in a way to adapt it to like more a human tissue, or we do remodeling also in alternative pregnancy. And so yeah, we need to personalize the model at least from one species to another, and then maybe one step further from individual to individual.
And we do not necessarily need to rely on the absolute data. We need to understand are the trends. If this go high, will the risk be higher or lower, or how it will evolve and interact with the other factors? This is why we do this parametric study. We don't necessarily need to fit in the physiology interval. We need to go beyond this. And we may sometimes go into places in the parametric space that don't really make sense. Something you would never find in the real population. This will help us to cover the space and explore actually what is the influence of different parameters.
Well, I think with Nicola being the man that can change uncertainty to almost certainty,
I'm glad
he would be
here
the best person to respond to you. But
now I understand.
clinically, I'm uncertain, but when it comes to dealing with data,
Now I understand to Google, I will send it over later.
yeah.
Hey, you did.
Just a small question.
Yeah, please. We still have about 50 seconds. So. You're on.
You showed that software was Iris, which was really nice. Do you think we can access it and the source code and complete it with the biomechanical harm?
The short answer is potentially yes. Obviously, this was published a few years ago. I need to go back to this whole team and to see whether they are happy or not, particularly the people who own the database, which is Oris University at that time. With this model, one of the things why we we never rolled it out. It was mainly for medical legal purposes. What validated we thought people might use it for the wrong purpose. One of the issues which you touched upon in any model is are you keen on precision, or what's the other one? Recall. So is it recall or precision? And in this context, are we trying to make sure that we pick up an obstetric illustrative injury when it happens? Or are we trying to predict the patient at risk of developing one? And of course, the recall and the precision will be totally different depending on what you're trying to do. Because if you know somebody is at high risk for oasis, what are you going to do? I'll cut an episiotomy to reduce the risk, which for many people might think, okay, it's okay, I can live with that. But if, like in this one, if you think, well, the only way really to reduce the risk is to do a cesarean section, if a patient says, I want my risk to be 0, then you could end up in a situation where your prediction model is just increasing significantly major surgery without any proper validation that it makes a big difference at the long term. But it might actually reduce even the risk of pelvic floor disorders at the long term, but would increase the risk of intraperitoneal adhesions and maternal mortality and lots of other things. So this is the difficulty with clinical prediction models. It's easy if you only have one parameter and one outcome, but in reality, of course, you have many parameters and so many outcomes. But that's why I said the short answer is yes, we can use it, but the long answer for what exactly? I think we'll bring the open day to a close. Do you agree? Thank you so much. First and foremost, to Fanny for hosting us. This would not have happened without you and sorting out the IT and the beautiful room and the beautiful city. So thank you for that. And thank you to all the speakers for sticking to time and really giving such amazing clear presentations that are thought-provoking in a very positive way. And thank you for the attendees, either in person or online, for joining us. I hope we could interact with our online attendees, but maybe for the future we can consider. So thank you very much, and have a nice evening.